This is part 4 of the Module 9 lecture. In this section, we're going to talk about an example where we compare the variances of two independent populations. In this example, a drug manufacturer is concerned about the length of time a particular drug retains its potency. So a random sample of 12 bottles, sample 1, was obtained from the production line, and each bottle was analyzed to determine its potency. A second random sample of 10 bottles, sample 2, was obtained from the production line and stored under controlled conditions for 1 year. Then potency readings were obtained on these bottles at the end of the year. The statistics from each sample are: here is the average for the average potency for the first sample and the variance potency for the second sample. Here's the mean and variance for the second sample. So we want to determine at a significance level of 0.05 if the two population variances are equal. All right, as I show you in previous problems, the first thing is summarize the information that you are given. So we know that these are two independent populations. We know the sample size 1 is 12. The mean of the first sample is 10.37. The variance of the first sample is 0.105. The sample size for sample 2 is 10. The mean for sample 2 is 9.83, and the sample variance the second sample variance is 0.058. That we have a significance level of 0.05, and in this particular problem we want to determine if the two population variances are equal. Now I wanted to point out that the first variance and the first point variance estimate, 0.105, is larger than the second point estimate, of the variance, which is 0.058. All right, so this is important because we're going to see how we're going to arrange this in the F statistic or the test statistic. All right, so this is step 1. In step 2, we state the null hypothesis, define the direction of the test, and specify the significance level. So in here, the objective is to see if the variances of the potency of these two drugs at these different times is the same. And these are independent populations because the first sample was obtained immediately after the bottles were produced, and the other bottles were taken, they are separate, and they were stored for 1 year under the potency measured. All right, so this null and alternative hypothesis in terms of equality and inequalities can be transformed into ratios, and as we did before. So now the null hypothesis, the ratio of the two variances is equal to 1 versus the ratio of the variances not being equal to 1. All right, so this is a two-tail test because we have an inequality sign in the alternative hypothesis, and as we saw before, the significance level is 0.05. All right, the second step is select the distribution to use. So these are random samples taken from two independent populations, and because these are random samples, the observations within each sample are independent. Also, we're making the assumption there is nothing said about what the distributions are for these two populations, but we're going to assume that they're normally distributed, or that these two are normal distributions. So in practice, we will have to look at the data that was collected and determine whether or not they are normal. All right, this is a two-tail test, so we cannot assume that one variance, or it is not assumed that one variance is larger than the other. So we're going to rely on the point estimates to determine which variance goes in the numerator of the test statistic and what variance goes into the denominator. As we saw here, the variance for the first sample is the larger one, so that will go in the numerator, and the second one will go into the denominator. So because of that, then the degrees of freedom 1, that corresponds to the variance that goes in the numerator, so it's 12 minus 1, that's 11 degrees of freedom, and the degrees of freedom for the denominator, which is for the second variance, and those are 10 observations minus 1, so the degrees of freedom will be 9. So this is the F statistic that we will use. All right, so the next step is calculate the test statistic. And as we mentioned in the previous slide, so the first the first point estimate of the variance is larger than the second point estimate. So this first variance will go in the numerator of the test statistic, and this variance will go into the denominator. All right, so it's very important to keep track of what variance goes where. And also remember, these are variances. So fortunately in this problem, they gave us the variances. But if there are problems where they give you the standard deviations, remember, you need to square the standard deviations so that you obtain the variances. All right, so the observed value of the test statistic is 0.1803. All right, so now we need to determine where the rejection regions are. So this is a two-sided test. Of course, there are two rejection regions, and to find them, we need to split the significance level in two. So alpha over 2 will be 0.025. So if you go to table 7 for the look at the sheet where the probability is 0.025, then find the column for 11 degrees of freedom, then go down until you find the row for 9 degrees of freedom. And you will find that the F value at that intersection is 3.91. So this gives us that upper value, and so the rejection region is to the right of 3.91, or for values larger than 3.91. To find the lower value, to identify the lower rejection region, we take the inverse of 3.91, and that's 2.558. So the rejection region on the left side will be for F values smaller than 0.0256. And that's what I'm specifying here as the rejection region. So to make a decision about the null hypothesis, we see that the calculated value of the test statistic is 1.8103, and is in the non-rejection region because it's larger than 2.56 and smaller than 3.91. So because it's not in the non-rejection region, we do not reject the null hypothesis. So we cannot say that the variances are not equal. So to interpret that decision, we will say that the variance of the population of the potency of the drug immediately after it is produced, and the variance of the population of potency of the same drug after 1 year of storage are equal at a 5% significance level. All right, so this is one example of how you compare the variances. In the assignment for Module 8, Part 1B, there are two problems already posted on Blackboard where you can will have a chance to solve two problems where you compare two variances. All right, so I'm going to stop here, and then in the next section we'll talk about comparing the means of two independent populations with equal but unknown variances.